solving equations using absolute value. Remember, absolute value is the distance a number is from 0. So this distance where -3 is from 0 is the same as the distance 3 is from 0. All right, last section we did variables on each side of our equation. Now we're going to use absolute value with equations. We're also going to use expressions with absolute value. You will use it in problems that look like this that have a margin of error. Here, there was a survey that was done and had a margin of error of 3%. So, you know, most popular types of books read in the U.S. in 2007. 66% were religious, 50% were popular fiction, and 20% were romance. But there was a margin of error of plus or minus 3%. So this column could have actually been someplace, it could have been as low as 63%, right? Or it could have been as high as 69%. So that's the margin of error that we're going to actually use absolute value in our equations. So to solve an expression using absolute value, all you're going to do is substitute in the value for the given variable. That's not going to be very complicated. We'll do those in just a second. And the expressions define, like we said, the upper and lower range in which a number may lie. So for instance, we have our political polls, right? And right now it's tied. And that means but it also says the poll of 816 likely voters had a percentage of error plus or minus 3.4%. So say it was a tie at 50-50, it actually could be one of these guys is ahead or behind by 3.4 percentage points. Football game point spread, Kentucky, Missouri is 14.5 points right now. So that, again, we could use absolute value for those kind of problems. Let's solve one of these expressions. Here we have the absolute value of m plus 6 minus 14. This is an expression, right? There's no equal sign. And we know that m equals 4, so we'll substitute in. Absolute value of 4 plus 6 minus 14. Absolute value of 4 plus 6 is 10 minus 14. The absolute value of 10 is what? 10 minus 14. 10 minus 14 is 4. So the solution, this expression evaluated is 4. Those are pretty straightforward. That's the easy part. None of it's very hard though, guys. All right, here's one for you to practice. Do it and get back with me. All right, let's go back to our telephone poll with the books and all that stuff, right, guys? Remember, we have a margin of error of plus or minus 3 points. All right, well, let's look at what that looks like on the number line so we clearly understand what it says. So we're saying the poll was at 66%. But there was a margin of error of 3 points. It could be 3 points that way, or it could be 3 points this way. So then we know it could be any place between 63 and 69%. There are 3 types of open sentences. And what's an open sentence? It's just an equation with a variable, all right? There are 3 types. There's that involve absolute value. Absolute value of x, where x, the absolute value of x is some number. Then we have the absolute value of x when it's less than some number, and the absolute value of x when it is greater than some number. Fortunately, right now, all we are going to talk about is the absolute value of x when it's equal to a number. We'll do the inequalities a little bit later on. So if x equals 4, if x equals 4, then we know that x could either be negative 4 or it could be positive 4. All right, so the solution set is negative 4 and positive 4. Let me say this a little bit differently for you, see if this helps clear things up. So we know the absolute value, oh gosh. So we know the absolute value of x, right? That means plus or minus x, doesn't it? That's what absolute value is, right? It'll be the is the plus or the minus of that. So negative x equals 4, right? Divide by -1, divide by -1, x will be -4. If we use the positive x equals 4, then x equals 4. So what are our two solutions? -4 and 4. So for each absolute value equation, we have to consider both cases. We have to consider both of the cases. We have to consider the positive and the negative, all right, possibilities. Also remember, when you're doing an absolute value equation, you first want to isolate the absolute value on one side of the equal sign. In general, that's going to be the case, how they'll be set up for, the problems will be set up for you guys. But if they're not, you have to move everything, all the absolute value stuff, isolated on one side of the equation. Remember, when you're reading in math, this symbol right here is read the absolute value of the quantity of f plus 5. I think you guys already know that. And in summary, when you're solving absolute value equations, you have to consider both cases. You have to consider case 1, where the symbol is positive, and case 2, where the absolute value symbol is negative. And now let's look at a problem so we can really see what this means. Okay. Here we have a problem. The absolute value of f plus 5 is 17. So we're going to consider the positive and we're going to consider the negative. So we're going to solve this problem twice. We're going to say f plus 5 equals 17, and we're going to say f plus 5 equals negative 17 to find the two solution sets, okay? So -5 minus 5, we find out that f equals 12. Over here, we're going to subtract 5 from both sides to solve for f, and we find out that f equals -22. So our solution set is both of these answers. It's a solution set of 12 and -22. Those are all the possibilities. And if we graph that on a number line, of course you'll use a ruler, and it does ask you to graph the solution set with these problems. Here's 0. Because they're such big numbers, I'm gonna do increments of 5. 5, 10, 15, and 20. Okay, so to graph this, f is 12 would be about right here. And f is -22, it's going to be over here someplace. Nice, neat graphs, rulers, arrows, etc. You know how to do this stuff. Okay. In this equation, b, the absolute value of b minus 1 equals -3. Think about what this means. This means that the distance between b and -1, I need an absolute value sign, thank you. The distance between b and -1 is -3. A distance cannot be negative. Therefore, your solution set is 0. You have to remember what you're actually solving for here. That when we're talking about distance on the number line, so distance cannot be 0. All right, here's your guided practice for this. Go ahead and do these two problems, and I'll see you back in a second. All right, Here's our real world problem for the day. We have this anaconda, everybody's favorite pet snake, I guess, right? Ooh, it looks like Costa Rica. Ugh, I hope there are none of those there. Okay. Absolute value equations occur in real world situations, and as we talked about, they describe a range within which the value might lie. So here we have our snakes. The temperature of an enclosure for a pet snake should be about 80 degrees Fahrenheit. Give or take 5 degrees. Find the maximum and the minimum temperatures. Okay. So what we could do is you could use a number line to solve this problem, or you can use some algebra, and we'll do both, okay? So here we have, we know that it's at 80 degrees right here, right guys? And it says it could give or take. It could be 5 degrees more, which would put us at 85 degrees, or it could be 5 degrees less, which would put us at 75 degrees. So the maximum that it could be, max would be 85 degrees, and the minimum would be 75 degrees that the temperature could be, and let the snake still live. We can always also think of that as an algebraic equation and write the absolute value and an equal sign, right? And we would say the absolute value of x minus 80 equals 5 degrees, because it's going to be at 80, and whether and the range is 5 degrees. So let's look what happens. So if we have x minus 80 equals 5, and x minus 80 equals negative 5, all right? So we'll consider the positive value first. So I'm going to add 80 to both sides to solve for x. And x equals 85, right? I'm going to now do the negative consideration, and I'm going to add 80 to both sides, and x equals 75. So our solution set is 75 and 85 on a number line looking something like that. Here's your guided practice. Try this problem. And try it both ways. Try to graph it and try to do the algebraic equations. Okay, the last thing we're going to talk about is given a graph like this one, where you have 11 and 19 on a graph, you can write an absolute value equation for the graph. So given 2 points, you can write an absolute value equation. Let's see how we do that. First thing we're going to do is find the midpoint. Find the midpoint. All right, easy way to find the midpoint is take 11 and 19, add them together, and divide by 2. 11 plus 19 is 30, divided by 2 is 15. So 15 is our midpoint. All right, now let's write our equation. Absolute value equals. What are we going to say here? What's the absolute value going to be? What's our range? What is our range between here and here? We need to know that number. It's 4, isn't it? And from here to here is also 4. So we're going to say x minus 15 equals, the absolute value of x minus 15 equals 4. All right? Why don't you guys try one of those? There you go. And I will see you guys tomorrow or Wednesday. Thank you.